4 times 180. What do you think the pattern is?
1, 2, 3, 4.
What's the relationship between 3 and 1?
You subtract 2 from the number of sides.
So I subtracted 2 from the number of sides. And what do I do to that number? Times by 180. So when you got to this random polygon, how many sides to this shape?
7.
So what should have been the calculation?
5 times 180.
5 times 180. Number of degrees.
720.
Okay. The next 1080. How'd you get 1080?
Add up 180. You just add the other 180, right?
Alright. So, before I started this, I said that you guys could either use the protractors or you could figure out a way to do this without it. And I didn't notice too many people trying it without the protractor. So here's kind of how it goes. 3 sides, what kind of shape? Triangle. And you guys understand that there's 180 degrees in the triangle, right? And then we were designing this investigation to kind of go beyond that. How many triangles do I have?
2.
So if this adds up to 180 and this adds up to 180, that's 360.
Yeah.
How many triangles?
2.
Adds up to
180.
and 180. It doesn't really matter how I split these, as long as I connect a corner or a vertex with a vertex. How many triangles are you going to get? 2. What number did I times by 180? Okay, so that didn't require me to measure anything. Go to the next shapes, the pentagons. How many triangles?
3.
3. What number did I multiply by 180? Even these random looking ones. How many triangles? How many triangles do you think I'm going to get in a hexagon? 4. Let's see if it happens. So I start here. There's 1. 1, 2, 3, 4. How many triangles?
4.
You can even kind of split it off. How many triangles?
4.
So that's where the pattern, that's why the triangle at 180 is so important to us, because we don't need the protractors, which kind of have a little bit of human error involved in them. Okay, there's a little human error. This gives you an exact answer. Okay, so the formula you want to have, how many degrees in a 10-sided figure? What do you think? If you kept on following that pattern, what do you think? Okay, you're telling me 8 times 180. So the part that you do not want to lose, right here. Okay, so the interior angle sum formula. We're going to use what Dominic said last slide. He said 180 times the number of sides minus 2. Except we're going to use ends equal the number of sides. So frequently you'll see it like this. And n stands for the number of sides. Or sometimes, but not frequently, you'll see the number second. Now the same thing, where n equals the number of sides. Okay, so that's the formula that you want to star, you want to highlight, you do not want to forget, ever. Kyria, honey, did you get this down? It's on your notes. You will never lose it.
Why you not take my home?
Okay, is everyone done writing this formula down? No, excuse me. Alright, so the second part of the success criteria, we found a pattern involving the interior angles of a polygon. The second part of our success criteria was to complete Regents questions involving the interior angles of a polygon. So that is what we're going to do next. So please don't put your notes away, because this is your exposure to the types of problems you're going to do with this formula. Are you done?
Yes.
Okay, here we go. Alright. What is the sum in degrees of the measures of the interior angles of a stop sign, which is in the shape of an octagon? So those things you see every single day. How do you get 1080? So how would I use my formula that I just learned to be able to do this? 6 times 180? Zach, could you explain to me how you got the 6, just so in case someone else in the class doesn't quite get it? 8 minus 2. So the octagon told me 8 sides. I have 8 minus 2 times 180. So 6 times 180. You get 1,080. So are there any questions on this type of problem? No. Alright, so this is the type of problem that you can see. The wording, multiple choice, fairly common. And as a teacher, I hope that this is one that you never get wrong. Okay, the next one. What is the sum in degrees of the measures of the interior angles of a pentagon? Of a pentagon. How would I do that one, gentlemen? How do you get 540? 3 times 180?
Yes, 540.
Miguel, do you agree?
Yeah.
Did you put this in your calculator?
Yeah.
So tell me what I need to do. 3 times 180? That's all? Alright. So again, if we're going to use the formula, you would put the 5 in there because it's a pentagon. Alright, the measure of 5 of the interior angles of a hexagon are 150, 100, 80, 65, and 150. What is the measure of the 6th interior angle? So what do we do for this type of problem? We kind of increase the difficulty. Darius just said add them all up. So what do I get?
Thank you all.
So I added them all up. What'd you get? She's gonna let you borrow it now. She's not monopolizing you any longer.
75.
795. I got 745.
645.
I got varying answers. I heard 645.
485.
Yeah, I got 645.
720 minus 645.
What'd you do?
720 minus 645.
Where'd 720 come from?
All six-sided angle and 720.
So a six-sided shake.
At 720.
How'd you get that?
Wait. 4 times 180.
4 times 180. And you got what? And then I take that 720 and subtract this.
Oh, the homework's on the goddamn back.
Katie, what do you get?
75.
Choice what? D. Okay, we feel confident about this? Yes? Darius? So guys, let's go back to our success criteria, because we're not going to get to all of them, but how did you guys feel about finding that pattern involving the interior angles of a polygon? You know, give me that thumbs up if you thought it was pretty easy, thumbs in the middle if you're really not sure, and then definitely a thumbs down if you don't have a clue what's going on today. Thumbs up. Thumbs up. All right. Completing the Regents questions. How do you guys feel about completing these Regents questions? Thumbs up if you're definitely good. Thumbs in the middle if you're confused. And thumbs down if you have no idea what's going on. All right. I'd like now to switch modes. I'd like to start looking at the other success criteria. Okay, we'll get started on that. And it deals with exterior angles. Okay, so we're going to look at exterior angles today. Yeah. All right. So our investigation is based on what is the sum of the exterior angles of a decagon. What kind of shape is a decagon again? 10-sided. And I'm just curious, do you think the exterior angles of a decagon will add up to be more than a quadrilateral or less than a quadrilateral?
More than.
More than. Okay, we're going to try and find a pattern. And your idea right now is that a 10-sided object will have a sum larger than a 4-sided object. And let's see if this actually comes true. Okay, so these...
So why do you go so many?
Or would you rather write it down?